Hello again, our most valued student. My name is Confident. Welcome to our review session of the Science N3 paper that was written on the 3rd of February. And by the way, this is Engineering Science N3, and these exams were postponed from November, and this time they were written in January and Feb. So I'm looking at the review of this paper. Before I start that, I will encourage you guys to subscribe to the channel. If this is your first time to come in contact with this channel, I will encourage you to subscribe, as well as ensure that the notification bell is turned on so that you can be notified every time there is a new video that we are posting. And also I would like to say to those guys who want to benefit from more videos on this channel, I will encourage you to become a premium member. If you become a premium member, what happens is whenever there are videos that we want to bring in, you are at a position to view more of these videos. For example, I'm going to do a full review of this Engineering Science N3 paper, and it will be available first time to premium members. Premium members are those who contribute a small monthly fee just to get those videos, and to us they go a long way in maintaining this channel, in ensuring that we're bringing new videos time and again, as well as ensuring that our content is always up to date. So I will encourage you guys, if you're not a premium member, please do so as a way or a token of appreciation of this channel. So without wasting time, let us dive into this quick review. As I said, I'm just going to be quick just to show you what the question in a way was about. And this is Engineering Science N3. You can see the paper was written in the morning. It's a 3-hour paper, and it is out of I think it's in the next part where they tell us the mark allocation of this paper. This is out of 100 marks, so it's 3-hour paper out of 100 marks. And a few instructions that sometimes get taken for granted. It says you need to, especially instruction number, let me see, this instruction is instruction number 4, leave your answer in 3 decimal places. Very important. And number 5, it says all calculations should consist of at least the following 3 steps. Please take this into consideration. The first one, you need to tell us about the formula. Okay. All right. And then the second one, the substitution into the formula. And then the third one, always leave your answer in the correct SI units. Don't forget that. It is very, very important to follow that plan so that you get more marks. And then the other part, use G. Don't forget the value of G. So G is 9.8 meters per second squared. So that is very important, guys. But I think also what is important to show you is that at the back of this paper there is a formula sheet. So this is your formula sheets, the formulas that you require. It's page 1 and page 2, and then there is the information sheet that they also provide here. They didn't bring in G. Remember, they said you must use G as 9.8 meters per second squared, the force of gravity. And then but don't forget the information sheet here. It is very, very important. So these are the formulas. But now looking at this question, question 1, it was on motion, power and energy, and the good part, or the interesting part, is they brought in a multiple choice kind of questions. Each question was of different marks though. It says the various options are given as possible answers to the following questions. Choose the correct answer and write only the letter A to D next to the question number 1.1 to 1.9 in the answer book. So guys, sometimes students just lose out this. You find that they are saying question 1.1, and then instead of saying if the answer was B, you're supposed to write B. You find students actually writing kilogram dot meters per second. Don't write this. You just have to tell us, is it A or it's B? So don't just make errors there. So that is that part. So I'm not going to go through this, but it was mainly on the topic or the module of motion, power and energy. By the way, do not leave blank spaces on multiple choice. If you have tried all the questions through, any question that you don't know, you can leave it blank for the time being. But before the time is up, ensure that you go back to that question. If you don't know anything at all, just like anything, guys, where you are playing some, whether is it a lotto or is a guessing game, you better guess what if it's correct than to leave it blank. Remember, this is a multiple choice. You might actually get it right just by guessing. Who knows? Who can tell that you're guessing? But that 1 mark or 2 marks that you lost you being in a way, I don't know what I call it, to leave it as blank. Whether I'll call it being the most honest person, I don't know. But I've seen students leaving multiple choice questions blank. So this is your multiple choice that you're supposed to go through. As I said, I will look at this full how these are sometimes one of the challenging and most tricky questions is the multiple choice, because the answers are very close to each other, but there is always the best answer, So this was that. I will show you a technique in answering these and eliminating answers so that you can remain with the best answer. Out of 16 marks was this module. And then coming to module 2 or question 2, which was following on the module of moment, the moment of a force. You see there is the definition. Define the moment of a force. You need to know that definition. Remember the clockwise and the anti-clockwise moments. And then they give you 2.2 here. 2.2 was talking about you being able to say a uniformly distributed beam with a length of 10 meters has a weight of 5 newtons per meter and is supported by 2 supports. So this is a matter of you coming in to have a sketch. Says construct. So you construct the 10 meter. If you still remember, I do also hear quite a lot in N1. And then from these, then you are going to put 2 information here to say one support is 2 meters from the left. That's where now you are going to look at 2 meters. You put a support and that distance there is 2 meters. And the other is 3 meters from the right end. You look at the right end, you come here to say that distance there is 3 meters. So, and this is a 10 meter, meaning the distance between here and there is 5 meters, and then you just read this information. Also, it says it also holds 3 concentrated loads as follows: 40 newtons from the left end. So this is my left end here. You've got that 40 newtons. And 30 newtons on the right end. You come here, there is 30 newtons. It's good also to put the units there. And 10 newtons, 2 meters from the right end. So you come here, you got 2 meters. There is a support just before the 3 meter, which is 10 newtons. And then from there, you do the calculate the reactions, blah, 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 blah. So guys, that was that. But as I said, I will do this much proper in the section where I'll do the full review. Then this question 3 was on forces, a very important one on forces. Figure 1 below shows a system of forces. Here they will want you, always they ask you to find the sum of the horizontal and vertical components, and it's 4 marks. It's just a given, so it's called resolving forces. So this one is already vertical, you take it as is, but the 20 kilonewton, you have to take the vertical component of it and the horizontal component of that. Remember, vertical has to do with sine theta and horizontal has to do with cos theta. So anything you're doing, if it's vertical, it's Fn dot cos and it's Fn dot sine. So you're taking that 20 here sine and you're taking the 20 here to be cos. So same thing here. If you're looking at this particular force here, if I can use that to say again, similarly, this becomes your cos, this becomes your sine. Vertically sine and cos. You are resolving even this force like that, and this becomes your sine, and this becomes your cos. And remember, it says the vertical components, it says the sum. So the sum of the vertical, you need to know, maybe you take up to be positive, meaning down it will be negative. So you need to add them accordingly. And also here, looking at the right as positive, the left will become negative. So you need to all consider all that. But it's a good question that you can use. It says calculate the magnitude and direction of the resultant force. So remember, when you come to magnitude, the resultant force, R, which is the resultant, is the square root of the x component squared plus y component squared. Let me check the formulas if ever they bring that into the formula sheet. Okay, they don't bring in the resultant, but don't forget this is the resultant. And when you're talking about the resultant here, don't forget to say the angle tan theta is equal to y over x. So that is very, very important for you to understand, and that's the direction of the equilibrium force. Remember, the equilibrium is always, if this was my resultant, the equilibrium is always opposite. This is resultant with a prime, meaning it is opposite to the resultant. So that is that. So whenever you are looking at the magnitude and direction, the magnitude is the one which is the r, the direction is in terms of theta. So guys, it's also a question that was good marks. It's not bad. Then the other part of the question 3.2, it was 6 marks to say you are given below the structure, and then you need to calculate the magnitude and nature of the forces of members. As you can see, the force in AB as well as the forces in BC. So it's also an interesting question, very basic. You just need to know what to do. Friction was module question 4. Here they needed you to tell us the 3 disadvantages of friction. 3 marks. I think it's a common question that you need to know, especially as you lay your foundation from N1 and N2. Then they give you 4.2, it says a granite block with a mass of 0.1 ton rests on an inclined plane. So this is an inclined plane kind of situation that they are describing here with a coefficient of friction. So this is not a smooth surface, it's a rough surface. Remember now, they are not telling us that it is being pulled up, they are saying it is resting. So if it's resting, you know there is the force of gravity which is linked to sine, and then there is, you resolve here, going directly down is your weight, but perpendicular to the plane is your cos. Remember that. And friction, always opposing motion, friction will be going up, and then like that is your normal, which is your reaction to that. So you need to know all this. Question 4.1, 4.2, 4.3 and 4.4, 4.2.1, 4.2.2, 4.2.3 and 4.2.4. they'll be based on this particular diagram. You just need to know this because they are very, very, very important. And then moving on, question 5. Okay, this question 4, I think yes, it was 11 marks. And question 5 was on the topic on heat. It's also one topic that is very, very important and carries quite a good marks in your exam. And then as I said, it's on heat. They give you the information here, and then after giving you the information that a 5 kilogram fuel is burned for 30 minutes in a factory, blah 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 blah, then all the information, then you need to now use the information above. Then you find the heat energy, the energy given off by fuel, the heat value, and the power given off. So it's a question also that is kind of standard. And then 5.2 talks about, is a continuation of question 5, which says the dryness factor of 5 kg wet steam is that. Okay, here they're dealing with wet steam, and then the steam is generated at a boiler pressure of 3.4 meters per pascal. Then calculate the specific enthalpy heat energy of the following. Okay, this is also common formulas that you need to use here that are based on the steam of water, so you can use that. Okay, moving on to question 6, which is on hydraulics. And with this question 6 on hydraulics, it says a single hydraulic pump needs to pump all water from a circular dam with a radius of that. The depth of the water in the dam is 10 meters. The water must be pumped through a height of that. Now when it comes to hydraulics, I will encourage you also, you work on your formulas. So it's a matter of you understanding your formula. So 6.1.1, 6.1.2. So it says calculate the following: the work done by the pump, the power required to empty the dam within 3 hours. And then 6.2 says the information below refers to the hydraulic jack, and it continues with that information. Now they ask you a question based on that information. So it's calculate the following: the force exerted by the ram, the distance the ram moved per 30 strokes, and the number of pumping strokes, the volume of liquid received, and it was 12 marks. Question 7 here, 7.1, it says a battery has EMF of that and internal resistance of that, and they gave you kind of a circuit diagram there, and then you need to calculate the information based on that. And then 7.2 also is a continuation of that. And then that was electricity, And then question point 8, the last question here is on chemistry. It's a small section. It says difference between metals and non-metals, and then state 4 precautions against corrosion of iron. So those are that was the end of the paper that they were asking here. But such simple things like this says a metal difference is a conductor of electricity, and then non-metals, they are usually non-conductors of heat and electricity, right? And then metals, another thing about metals, and yeah, one is a conductor of heat, is a non-conductor of heat, and non-metals is a conductor of electricity, is a non-conductor of electricity. And I think those are the basic one that I'm thinking of at the moment. And then state 4 precautions against corrosion of iron. In other words, how can you avoid iron from rusting? Things like painting, use paint, oiling, and then galvanizing. Those are simple things. Electroplating, electroplating, and then actually it's 4. So that these are what you can use to avoid the corrosion of iron. But now if I can go to 1 or 2 questions that I can do, maybe let's look at the last question. I think that would be better. The last question here before question 8, this is chemistry. Before that it's electricity. I think this is the question here. We can just quickly take a bit of time to look at this question on electricity here. To say 7.1, a battery has an EMF of 24 volt. So here what they are trying to say is the EMF here is equal to 24 volt, meaning the electromotive force is the potential difference or the voltage of the cell when it is not working. So it's 24 volt. And the internal resistance, so there is a small r here of 1,6 ohms. That is the internal resistance when connected in the circuit below. Then they want us to calculate a few things. Says calculate the following: the 7.1.1, the total resistance in the circuit. Guys, it's a common question about this, but for you to be able to find the total resistance, it's very, very important to trace your current. So the first thing is, remember, current flows from the positive to the negative, so it's flowing in this direction. And then when it comes here, the current is going to split or branch. Part of it will go that direction, part of it will go that direction. So if I can use different ways of labeling it, I can say this is our I total, this is our current, total current, that's our total current, this is our total current. But when it comes here, it changes direction. We'll say there is I1, and then here there is I2, meaning the second current, because it's split in this junction. So now if I follow the current here, the I2 will continue here, the I2 will enter the 7 ohm. So this is still my I2, and the I2 will also enter the 5 ohms. So if you look at these, because the same current is passing through them, they are in series. Now remember, resistors are in series. The formula now for resistors in series, I'm not going to go to the formula sheet, but for resistors, so for R in series, which is SER, okay, just for the sake of someone to say, but where do I get that? I think there are formulas for resistors in series. Just to quickly check here, I think yes, on this part there is the formula for the resistors. R, you see R series is R1 plus R2 plus R until Rn. Resistors in parallel, 1 of R1 plus 1 of R2 plus 1 of Rn, just like that. So these are the formulas that we'll be using here. So if I go back to this question to say, now since I'm saying these resistors here, they are in series, so what do I have is equal to R1 plus R2, which is equal to 5 plus 7, which is equal to 12 ohms. Are you getting that? So now, because it's 12 ohms, I can now redraw this diagram like this. If I cut here, I can have now something like that. That's what it means. So pretend this part does not exist anymore. So our diagram is like that. So when this I2 comes, it comes here as I2. You see that? So these two, because one is getting I1 and the other one is getting I2, we say they are parallel. Because why? They are getting two different currents. So this one, we say it is 12. This other one was 6. That's when you have to use the formula now for what? For parallel circuit, which is 1 over R parallel is equal to 1 over, the first one is 1 over 6 plus 1 over 12. You seeing that? Sorry about that, not 16, but it's 1 over 12. So now if you can add, because that's the part that you need to do to add that, say 1 over 6 plus 1 over 12, and then it will give us 1 over 4. So what we have here, we have got 1 over R parallel is equal to 1 over 4. But remember what happens now to find R parallel, you take this to the top and I take this to the top. What I do on the left, I do on the right. So I will have R parallel over 1, which is same as R parallel in a way, because anything divided by 1 doesn't change. And I'll also get 4 over 1, and 4 over 1 is same as 4. So R parallel is equal to 4 ohms. You see that? So I've got the, remember I'm finding the total resistance. So at the end of the day, this is a circuit that is reducing itself. So it was first 5 and 7 ohms, then it became 6 and 12 ohms. Now it is the 4 ohm, and when I draw this circuit, you'll be having something like this. If I look at this circuit, I can think of, just picture this one, we have removed it now. It is now 4 ohms, the total, then I cut it there. So pretend this does not exist. So you have got the 4 ohm. So if you have got IT, this is the total current. You see now, coming here again is the total current. I'll show you this in detail whenever I'm teaching the lesson on electricity. So you can see these two now are in series because the same current is passing. So if you find now the total current, which is IT, it is equal to 4 plus 2. But now remember they told us something hidden there. They said internal resistance of 1,6. You can see that the same current IT passes through this 1,6. So you add there and say also plus 1,6. So we're adding 4 plus 2 plus 1,6, which is equal to 4 plus 2, it's 6. 6 plus 1,6, which is 7,6 ohms. Maybe just to verify that, which is 4 plus 2 plus 1,6. You know, I just don't want to make a silly error. There's 7,6 ohms. So the total current here that they wanted is 7,6. So if you look at that question, 7.1.1, the answer is equal to 7,6 ohms. Are you getting that? So that is how you work on such a question. It's a bit tedious. It needs a little bit of carefulness. That's why it's 3 marks. Then the next one says the total current in the circuit. Now total current, remember this is not difficult now. You have got resistance is equal to a voltage over current. You remember that formula. You can use I think it's there even in the formula sheet. When you look at that formula for resistance, being a voltage over current, I can't see it here, but you definitely need to know that formula. Let me just check it here. If ever there is a formula for R is V over I. Okay, I can't see that one, but remember that formula. Resistance is voltage over current. Sometimes you use that triangle. Remember the triangle to say here VIR. So I can actually use this triangle for quicker work to say what is current. I is equal to V over R, because V is equal to IR. I said resistance is voltage over current. So I is V over R. Now I know the voltage, which is the EMF, which is 24, over R is the R total that we got, which is 7,6. That is basically what you are using there. Then you can get now the question the answer there that talks about the total current that is in this circuit. So if I can divide by that, it will be 24 divided by 7,6. It gives me, in this case, 3,15 to 3 decimal places. Remember, it's 3,1578. The 8 changes the 7 to 8 is 3,158. So this is equal to 3,158. What is the unit? It's amps. Remember, they said have a formula, substitute in the formula, leave the answer with the correct units. So that is basically that. And then the next question here says an electric kettle marked 750 watts, 220 volts. C is the specific heat capacity of that for the kettle. C is 4,187 kilojoules. Please take note of the units. There is kilojoules per kilogram degrees Celsius. Calculate the following. And then the quantity of heat developed in 5 minutes by the element. Now, when it comes to the quantity of heat, they are looking for Q, and there are many different formulas for finding Q. If I quickly go to the formula, you will see different formulas for Q. For example, I've got this one here to say Q is equal to M times C times change in T. That is one formula for Q. And again, I've got a formula for Q, which is P is Q over T, P being the power, Q being the heat energy released, and T being the time taken. And also, looking at another formula, I've got the formula again for Q. You see this formula, Q is I squared R, I squared times R times T, but the T here being the change in temperature. So you need to be very sensitive on using these formulas. So if I can come here and write those formulas, the first one was P is equal to Q over T, and the other one was Q is equal to I squared R. I would write change in T so that you can see the difference. This is for temperature, and again I have got Q is equal to, if I quickly check the other one, is MC. Actually, this one is the one MC change in T. Actually, let me not mix that. Actually, this is the one here. This is the time here. This is the time, not Q is MC change in T. That's the temperature. And then Q is P is Q over T. This is time. This is time. And this is temperature in degrees Celsius. All right. So now when you look at this question, it says calculate the quantity of heat developed in 5 minutes. Is 2 marks. So they gave me 5 minutes and they want the quantity of heat, and they gave me that. So this is my P, the power, and this is my T, and they want my Q. So you can see P, QPT is this formula, so that you've got P is Q over T. Now what is my P, which is 750, is equal to Q, which is the heat that they want to calculate, and then time is 5 minutes. But time, now you must say 5 minutes times 60 to convert it to seconds. So it's 5 times 60. Remember, from minutes you got to seconds. So if you now simplify this, you have to multiply by 5 times 60 this side, so that this goes, but what you do on the left you also do on the right. 5 times 60. So if then I use that, it will be 5 times 60 times 700, and then it gives me 225,000. This is 225,000 joules because J, or you can divide by 1,000 to become 225. So the answer there is Q is equal to 225,000 joules, remember, or 225. Now since we divided, it's kilojoules. You see, if you divide by 1,000, but it's fine to leave your answer in the first way. Guys, this was just the 4 marks here to say you got it as Q is equal to 225,000 joules. Okay, actually it's in the wrong place. It's the first one, which is Q is equal to 225 I'm just writing it down so that in case this answer continues. So we've gotten that. The next question says the time to heat 5 kilograms of water from 20 degrees to 98 degrees Celsius. So now you have to obviously look at the one that has got to do with Q. There is that one. So what we're saying, we are saying our Q here is equal to MC change in T. So it will be the mass of water is 5 times the C. They gave us that C as what? It's 4,1, but look at the units. It's 4,187. It's kilojoules, but we're working with joules, so you say times 10 to the power of 3 or times 1000, right? Times change in T, you say 98 minus 20. I think that. So what is it going to give us? It is going to give us the Q here. So if I multiply that, remember we are now not finding time. The question wants time, but we're calculating Q at the moment. So it's 5 times 4,187 times 10 to the power 3, okay, times 98 minus 20. All right, equal to, I get this number, which is 1632930. 1632930. 1632930. So I get this as joules, 1632930. That is my Q. But now, am I finding Q? No, I'm finding time. So you have to go back to the other formulas that link with time. So we said the first one, P and Q and T, it links with time. So we can use that one. Or we can use that, because the other formula, if you check it, it has got current, and we are not given any current at the moment. We need to find it. So to simplify it, we'll have P here is equal to Q over T, but we already got our Q, which is, and we got our P, and our P is 750 from the formula, is equal to Q, which is 1632930 divided by what? By time. Then how do you make T the subject? You multiply by T there, you multiply by T. See that? And then it allows you to solve for T. So what we have is, we are saying 750 times T is equal to the 1632930. I mustn't make an error there. Then you divide by 750 on both sides, just to remain with what? Just to remain with T. So in this case, your T will be equal to, when you're dividing there, it is 1632930 divided by 750. Remember, this is now converting it to time. This is 2177.24 seconds. So it's 2177.24. Time is measured in seconds. If you want to convert that now to minutes or hours, then you're going to say T is 2177.24. You divide by 60, converting it to what? You're converting it to minutes. And then if you do that part there, it then becomes 2177.24 divided by 60. It will become 36,287. So 36,287 minutes. You can divide by 60 to convert it to hours, but it was not necessary. So guys, this is how we go about that. And then the last part there, it says we need to find what you call 7.2.3. It says the current in the element, the current. So I'm talking about the current now. What is the current in the element? Back to our other Q, you could have used this one, or we can use a simple formula as 2 marks. The current there is not complicated. We have the formula which says P is equal to V times I, So P, which is 750, is equal to V, which is 220, times I. How do I find I? You divide by 220. I divide by 220. You see that? So if I use that as my formula to say 750 divided by 220, it gives me 3,409 in 3 decimal places, 3,409. So I is equal to 3,409. Remember, current is measured in amps. Now the one that I wanted also to do was this question. It was looking at this friction. Here it was asking things like list 3 disadvantages of friction. You know, friction, number 1, we have got a problem. It causes a disadvantage of friction. Number 1, it causes wear and tear, right? Number 2, it causes unwanted heat. Sometimes you don't want that heat. It can cause heat. It causes unwanted sparks. Number 3, it causes loss of energy. Losses of energy is friction. It leads to actually costs. You know, it leads to costs because wear and tear. Through wear and tear, you know, it causes you to spend. So that was that part. So you just needed to look at that. And then here, what they said, a granite block with a mass of that, rest on that. So on the next block, guys, I promise you, when I'm bringing this full version of the video, I'm going to look at all these questions in a way that is much slower. Because of time, I'm forced to stop, but I'm going to bring you a full version of this section. I hope it will help you to, in a way, understand these questions, and going forward, you'll be able to master the engineering science N3. We've come to the end of our lesson because of time and the limitation of the time I wanted to bring this lesson. I just wanted you to have a kind of a preview on this engineering science N3, just to have a sneak peek to say what is it, what was it about this paper. But remember, become our Prime member and you're going to get all these full videos. We've come to the end of our lesson. Thank you.